The next topic we're going to take a look at with our point-slope form is how to write an equation from a graph. So step one, we need two pieces of information in order to write an equation in point-slope form. We need the slope and we need a point. And you can find those in any order. So I have step one, finding our slope. Doesn't matter if you do that as step two. But since I've got it written down as step one, we'll look at that first. So we've got these two ordered pairs. I'm going to count my rise, which is 2, and my run, which is 8. Writing my slope in simplest form, rise over run simplifies to 1/4. Now when you're writing this in point slope form, you can choose any point on the line. I've got two that are identified, so those would be the easier 2 points to use. I'm going to go ahead and find this ordered pair, which is -2, 6. And then we substitute it into the asylum equation. I'm going to write it down again. Substituting our slope, we got was 1/4. Our x value is -2. When it goes inside the asylum, it doesn't act normal, so it becomes a +2. And outside the asylum, we've got a +6, so it stays normal as a +6. Let's take a look at that one more time with our example B, our blue line. Rise over run. In this case, to get from this point to this point, I'm rising 0, and I'm running, I'm going to approximate this, it's about 10. 0 divided by 10 is 0, so I end up with a 0 slope. Choosing either ordered pair, I'm going to go ahead and find the coordinates of this one. Looks like we've got 6, -3. Substituting that into our asylum equation. Substituting 0 for our slope. And then my 6 is positive, so when it goes in the asylum, it stops acting normal. It becomes a -6. My -3 goes outside the asylum, and it is normal, so it stays as a -3. And in this case, anytime you've got something multiplied by 0, we're going to go ahead and simplify this. 0 times the quantity x minus 6 is 0. So this equation simplifies to y equals -3. So as a reminder, horizontal lines, the y value doesn't change, so you get a y equals. You have a 0 slope when you've got a horizontal line. And then vertical lines have an undefined slope, and you get an x equals equation because the x value never changes along that line. We'll go ahead and do the next two topics, graphing from point-slope form. There's two different options to graph from point-slope form. So in this example, we're going to follow option 1, which is rewriting it into my form of point-slope. What you see right here is the real point-slope form. It's not quite as user-friendly as mine. So when you get to your book assignment, this is what you're going to see. So I wanted you to know how to work with it. So we're going to get y alone. I'm just going to add 1 to both sides. Now remember that 1 is not a like term with the -1/5 times the quantity x plus 3. All of that is being multiplied before we would add our 1. So I just throw it on the end. So to graph from point-slope form, we need the point and the slope. So remembering the fact that our generic equation is this, I identify my slope as -1/5, and then my ordered pair. Now I have to pull that +3 out of the asylum. So if it's a +3 inside the asylum when it's not normal, normally it would be a -3. And then outside the asylum we've got that +1, so it stays normal, so it's a 1. Remember, anytime you're graphing, you need to plot the point before your slope. Your slope is a rate of change between 2 points on the graph. So we've got to have a point before we can have a rate of change. So I'm going to plot my -3, 1. And then from there, I'm going to use my rise over run, -1/5. So I'm either going to fall 1 and go to the right 5. And I can do that again to use the whole graph. Or we can rise 1 and run to the left 5. Make sure your line has arrows on the end. All right, last example, option 2 for graphing from point slope form is to get the equation into slope-intercept form, meaning solve it completely for y and simplify everything that you can. So the first step that we would do is to distribute our 3. And then to finish solving for y, I'm going to add 4 to both sides, combining it with my like term. So we got y equals 3x plus 10. Once we have it in slope-intercept form, identify your slope and y-intercept and graph from there. So the slope, remember, is what you're multiplying your x by, and in order to have rise over run, we turn our whole numbers into fractions. And then the y-intercept is your constant. As I said last time, we've got to plot the point before our slope, so our y-intercept gets plotted first. And because it's at the top of my graph, I can't use my rise over run as a positive 3. Remember, a negative divided by a negative is also positive. So I can fall 3 and go to the left 1 and still get a positive slope. And again, I'm going to use the whole graph, so I'm going to keep falling 3 and running left 1. And arrows on the ends of my lines. Now here's some advice for when you want to use one option over the other. When your slope is an integer, it might not be a bad idea to put it in slope-intercept form, because then you'll get an integer for your y-intercept. When your slope is a fraction, like on this one, think about if we were to distribute the negative 1/5 times the 3. We're going to get a fraction, and then we have to add that 1 to it, so it gets a lot messier. So you want to take a look at that slope before you decide which method that you want to use to graph your line. And your U-try problems.